Hi, everybody. Welcome back to our second video. My name is Alex Palesandro, and I'm here with Alessandro Olivero and Aldo Lazzuku. Hi, guys.
Hi.
Hello.
So, today, we will talk about Lico, and we will see how you can build a simple hybrid cloud using Lico, facing an outage of resources, a shortage of resources in one local cluster. To do so, we will use exactly the same application we used in the first demo. You will find a link in the description. The idea is that we have here an application which is Online Boutique. The application we deployed the last time is a normal application. So from Google, we didn't modify it. And if we look to one container, so we see that they are normal deployments. They have one part that we modified, which is the scheduling part, where we said we want some of them to be on the local cluster and some of them to be on the virtual node, which is the node created by Lico, which handles resources from a remote cluster. So let's go ahead. We can have a look, for example, to an image of the container. So here we are. So we have the shipping service, for example, which is exactly the same image provided by Google. So as you can see, we are just pointing the repository for Google, so no modification from our side. And I think this is also, they are really simple deployments. This was the state of our cluster. So today we will try to modify the deployment and suggest a different strategy. The strategy will be prefer local deployment, so prefer to put pods locally. And when you are running out of space, you can use the remote resources which are mapped in the first cluster by the Lico node. So this is pretty much how it is done. Let's have a look to what we do to trigger this behavior. So the first thing you will do is to use another deployment, which is exactly the same, but which has inside the different strategy. And here we have, So we said, okay, not in virtual node, and this behavior, so this is an int to the scheduler, and the behavior is preferred during scheduling, ignored during execution, which means that the scheduler will try to satisfy this hint, but if it doesn't manage to do so, it will schedule this pod on available resources. So it's not mandatory. So let's try to apply this application, this new version of the application, and we can see that the first effect is a repatriation of the pods from the second cluster to the local one. So the pods which were offloaded by our previous deployment will be repatriated, and we will see that this repatriation is done more efficiently and without having without outages, because as we can see for the ad service, we still have one pod here, and this will be running until this pod, the local one of the ad service, will become available. So until that, we still will have the pod running on the remote cluster, and it will be able to serve traffic. In order to so it follows the rolling update strategy of the deployment. It's really compliant with what deployments do in local clusters. And when the one became available, the pod is terminating, and then this has disappeared, and there is nothing more here. So what we can do now is to say, okay, let's try to fill our first cluster, our local cluster, until we can we are required to use resources from another one. And so what we can do to scale resources here is really simple. We can just use the scale command. So
we show.
Yeah, we can show it here because it's simpler. So I've changed the context of this terminal. So we are now pointing to the cluster one.
Just a moment, it is blocked. I don't know why. Okay.
I think it's just Licodemo, exactly. And then you have We have all the local pods, and we will use -w, which means that we will see information about new pods and new pods updates in using these directions. They will be printed one after the other. And now we can trigger the scaling. So the scaling. So we will have 3 replicas for each deployment. And we can see that all the pods that are created now, they are not put on the other cluster. So they stay locally because there is some room left in the local cluster. Okay, so they are going up. We can see that everything is pretty much okay there. But what if we have our cluster which is full and we want to scale again? So for example, we put 4 replicas for each deployment. We can see that we have no room left locally, and we start using the remote cluster. So here we have your pods that are offloaded on the remote cluster on a local node here. But if you look to the nodes where those pods are created for the cluster 1, so here we are in the cluster 1, they are remotely scheduled. So we fulfill all the local resources as much as we can, and then we went on the other cluster. We offloaded pods on the remote cluster. So I think it could be worth to have a look to the application, which is still working. Yeah, so you have the application works, and we have a lot of deployment and a lot of replicas which are local, and some of them which are on the other cluster. And I think now we can also have a look to the endpoint slices. So as we mentioned in the first video, Lico takes care of service replication, or how we call in Lico this mechanism this is called reflection. So services that are in cluster 1 are available in cluster 2 in the twin namespaces. So here we are back in cluster 2. We changed the kubeconfig, and now we can see that we have for each service not only the replicas locally available on cluster 2, but also the list of pods which are available on cluster 1. So for example, that one. Those are pods available on cluster 1. So Lico keeps track of those replicas, and you may have all the endpoints available for your application across the different clusters. So I think we are done for today. Thank you a lot for your attention, and if you have questions, just add them to the comments. We will be happy to answer them. See you and bye.